In this video, I'll be covering question 6, part A from the 2023 AP Calculus AB free response, no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. So diving into A right now wants us to show that the derivative dy dx of that given equation is equal to the derivative that they gave us. So we need to go and take the derivative of this equation. When we see x's and y's variables kind of commingling together on a problem, bells and whistles have to be going off that what you're looking at here is an implicit differentiation problem. So in order to take the derivative of this, we're going to need to dx the entire equation. You know, this one's pretty straightforward. It fits with what we're used to with the dy dx. You know, if you had some other variable on the bottom here, that would tell you what you would want to do, d whatever to this equation. My rule, my little saying that I use when I'm doing implicit differentiation is every time I take a derivative, I get extra stuff. And what that extra stuff is going to look like is envision there being this little box behind that d up on top. And when I take my derivative, I'm going to get d, and then I'm going to fill that box in with whatever I took the derivative of over dx. So working our way through this a chunk at a time, I come to this first piece here and I have 6x times y. Well, remember, chain rule, product rule, quotient rule, all these rules still apply as you're doing implicit differentiation. So if you've got two things being multiplied, that means you need to apply the product rule. My product rule recipe goes fg prime plus gf prime. So I would label one of these chunks the f piece, the other chunk the g piece, and then I break them into their bite-sized little math problems. So f would equal 6x, g is going to equal y. To find my product rule pieces, I need to go find an f prime and a g prime. It's when I go find the f prime and the g prime that I'm actually taking the derivative and I get my extra stuff out. So finding the derivative of f, the derivative of 6x would just be 6 following our power rule. And then I took the derivative of an x, so I get a dx. Go to find the derivative of g. Now g prime, the derivative of y would be 1. I took the derivative of a y, so I get a dy dx. Now I just call these my ingredients. Now that I have all my ingredients, I need to follow my product rule recipe to get my derivative. So I just work my way through it. The rule says first go grab f, so I go grab f. That would be 6x. Then multiply that by g prime. I'll kind of clean it up as I go. I don't really need 1 times dy dx, so I'm just going to call that dy dx. Plus, it says go grab the g piece, which is y, and then multiply that by my f prime. Again, cleaning this up, when you get a dx over dx, anytime those two pieces match, it's like having 5 divided by 5, right? Those things cancel out. You're really looking at 1. So then I end up with a 6 here. There's my product rule on that left-hand side, and then I keep working my way through it. Equals the derivative of 2, the derivative of a constant, a number by itself, no matter what method you're using, is always 0. And then the derivative of y cubed, that's taking it how I normally would, power rule, bring the power down, subtract 1 from the power, and then I took the derivative of a y, so I get a dy dx. So now I've gotten rid of the calculus portion of the problem, and the rest of this is really just a big algebra problem. I need to solve for dy dx. I'm trying to get dy dx by itself. When you've got multiple dy dx's in a problem, the game becomes the same every single time. You want to get everybody that has a dy dx on one side of the equals, and everyone that doesn't have a dy dx, you're going to move to the other side. So the easiest way for me to do that is just to move this one piece from the left side over to the right side. So minus 6x dy dx. Working our way through that, that stuff would cancel out. I'm going to go ahead and rewrite that to make more sense. That would just be 6y is how we're more comfortable seeing that. And then we get 3y squared dy dx minus 6x dy dx. The reason we do this move every single time is because now that everybody on this one side has a dy dx in it, I can factor a dy dx out of everybody. I can pull a dy dx to the front. And that's going to leave me with 3y squared from the first piece and a minus 6x from the second piece. Now you can see that I have two things being multiplied, so to get that dy dx by itself, I'm just going to divide both sides by 3y squared minus 6x, divide by 3y squared minus 6x. And out of there, I will get 6y over 3y squared minus 6x equals, those cancel out, and I get dy dx all by itself. The last move on here is just a little bit more of factoring, a little bit more simplification. You'll notice our answer doesn't quite match what they have going on up top here. And that's because they want us to pull out a common term on the top and the bottom. So if I kind of pull this over here now, so we have a little bit more room to work with. 6y, 3y squared minus 6x equals dy dx. You'll notice that really I have a 3 on top and a 3 on bottom that I can pull out. So I pull a 3 out of the top here, and that's going to leave me with 2y. I mean, technically you probably wouldn't do that, but this is just to illustrate it for you. Then on the bottom, I've got a 3 in both pieces. I can pull that out. That would leave me a y squared from the front piece. Pulling a 3 out of that 6 is going to leave me with a minus 2x. And all of that still equals dy dx. And then the final move here, now that I can see that I've got that extra 3 everywhere, is to cancel that 3 out. And I'm left with 2y over y squared minus 2x equals dy dx. And we have now proven or shown that our derivative does equal that. So we would have gotten out of here 1 point basically for making it through the first part of your implicit differentiation, and then you would have gotten a second point for getting it all that algebra set equal so that dy dx equals what they said it should. Thanks for watching my video. If you liked it, please click that like button and subscribe, and also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.